The universe has a story. It's a 13.8 billion-year-old epic, and for decades, we thought we had the plot figured out. It was a tale of slow, patient creation, where tiny seeds of matter gradually grew into the huge, star-filled galaxies we see today. It was a story that made sense, one that fit our scientific models. But what if the beginning of the story is all wrong? What if the universe wasn't patient at all? What if it was in a massive hurry? Humanity's golden eye in the cosmos, the James Webb Space Telescope, has peered back to the dawn of time and found something that, according to our rulebook, shouldn't exist. It has found cosmic giants in the nursery of the universe, galaxies, so massive and mature they shatter our understanding of everything that was supposed to come after. This isn't just a new discovery. It's a cosmic puzzle that forces us to question the very story of our universe. Imagine planting a redwood seed and finding a fully grown tree just a few days later. It's a paradox, right? An impossibility that would make you question everything you know about biology. Well, that's the exact scale of the puzzle astronomers are dealing with right now. The James Webb Telescope has found the cosmic equivalent of that redwood. These aren't the small, baby galaxies we expected to see in the early universe. They are massive, well-formed structures, brimming with stars, at a time when the universe was just a fraction of its current age. One of these galaxies even appears to be more massive than our own Milky Way, but it had billions fewer years to pull itself together. Their existence throws a giant wrench in the gears of cosmology. It's a discovery that has left astronomers with one thrilling and deeply unsettling question. The established story, the slow cooker universe. So, why is this such a big deal? To get it, you first need to understand the old story of the cosmos, the one we've been confident in for over 50 years. The story is told by something called the Standard Model of Cosmology, or the Lambda-CDM model, and it's been incredibly successful, explaining almost everything from the faint afterglow of the Big Bang to the web-like structure of galaxies we see today. At the heart of this model is an idea called hierarchical formation. Think of it like building a castle with Legos. You don't start with the whole fortress. You start with single bricks, click them into small walls, connect those walls to build towers, and then arrange the towers to create the final, grand structure. According to the Lambda-CDM model, that's pretty much how galaxies form. The story starts in a very young universe that was surprisingly uniform. There were just tiny, almost unnoticeable fluctuations in the primordial soup of matter and energy. This is where dark matter, the mysterious, invisible stuff that makes up about a quarter of the universe, takes. Pockets of slightly denser dark matter acted like cosmic seeds. Their powerful gravities started pulling in the hydrogen and helium gas around them, the ordinary matter that would eventually become everything we can see. Over hundreds of millions of years, these small pockets were supposed to grow into the first tiny protogalaxies. Not the beautiful spirals we know today, but small, messy, chaotic collections of the very first stars. The established theory predicted these were the only kinds of things the JWST would find in the early universe. Faint, small, primitive galaxies. The grand structures were supposed to come much later. This whole process was thought to be painfully slow. These little protogalaxies would orbit each other, get tangled up in each other's gravity, and over billions of years, they'd collide and merge, getting bigger and bigger with each cosmic smash. Our own Milky Way is a product of this, a galactic city built from the rubble of smaller galaxies. It has eaten over its lifetime. This slow, bottom-up construction was the foundation of our understanding. It painted a picture of a universe where the first billion years were for laying the groundwork, not for building skyscrapers. And for decades, our best telescopes, like Hubble, showed us things that seemed to fit this story perfectly. The further back in time we looked, the smaller and more jumbled the galaxies appeared. The story worked. Until, suddenly, it didn't. The impossible discovery. Cosmic giants at dawn. When the James Webb Space Telescope opened its powerful infrared eyes in 2022, it was designed to see exactly what the model predicted. Those faint, infant galaxies at the dawn of time. And it did. But it also saw something else. Something no one expected. Just 500 to 700 million years after the Big Bang, JWST found galaxies that weren't small and primitive. They were colossal. They were mature. By every rule we had, they were impossible. These weren't just red blurs. They were structured, massive systems, some appearing to hold over 10 billion times the mass of our sun. To put that into perspective, it's like finding a fully grown adult who is only a few months old. The standard model just doesn't have a way to explain this. It predicts that this early on, there simply wasn't enough time for gravity to gather that much stuff in one place. To get this big, this fast, these galaxies would had to turn nearly all of their available gas into stars with terrifying speed, way more efficient than the 10% rate we see in modern galaxies. The finding was so shocking, it made some scientists wonder if something was fundamentally wrong, either with our ideas about galaxy formation, or maybe even with our entire model of the cosmos. And it wasn't just about size. JWST also found galaxies that were way too structured for their age. It saw galaxies with organized disks, a feature that was thought to take billions of years of slow, gravitational settling to form. Yet here they were, already in place, when the universe was just a baby. But maybe the most shocking discovery of all was finding dead galaxies in an era that should have been bursting with new life. In astronomy, a dead or quiescent galaxy is one that's stopped making stars. It's run out of gas, or had it blown away. Now it just sits there, its bright young stars, long gone, leaving only the reddish glow of older, cooler stars. Scientists thought this was something that only happened to mature galaxies after a long, full life. But JWST found something that flipped that idea on its head. It discovered a massive quiescent galaxy, named Rubizu DSQGZ7, that had already stopped forming stars when the universe was only about 700 million years old. This galaxy managed to build over 10 billion suns worth of stars and then just quit, all in an incredibly short amount of time. According to our models, galaxies like this should be over 100 times rarer than what JWST is finding. It's like a cosmic crime scene where the victim seems to have died of old age just moments after being born. The existence of these massive, mature, and even dead galaxies isn't just a minor plot hole. It's a direct contradiction that might force us to rewrite the opening chapters of our cosmic story. The investigation unraveling the cosmic clues when faced with an impossibility, scientists turn into detectives. The discovery of these cosmic giants has kicked off one of the most exciting investigations in modern astronomy. Every new piece of data from JWST is a clue, and every theory is a suspect. The main question now isn't what are we seeing, but why. The investigation is following a few key lines of inquiry, each trying to explain how these galaxies got so big, so fast. First, the detectives had to double-check their evidence. How do we even know these galaxies are so old and far away? The answer is redshift. As the universe expands, it stretches light. Light from really distant objects gets stretched into longer, redder wavelengths. The amount of this redshift tells us exactly how far away, and therefore how old an object is. The galaxies JWST found have incredibly high redshifts, confirming they are from over 13 billion years ago, in the first few 100 million years of cosmic history. So the timeline is solid. These things are genuinely ancient. With that confirmed, the investigation turns to the suspects. The models are just wrong. Maybe the simplest answer is that galaxies form way faster and more violently than our slow cooker models thought. The lambda-c DM model is all about a gradual, steady process. But what if the early universe was more like a pressure cooker? Some new computer simulations suggest that star formation back then was under steady trickle, but happened in intense, explosive bursts. This bursty star formation could create flashes of light that make a galaxy look much brighter, and therefore more massive, than it really is. This could explain the surprising brightness without needing an impossible amount of stars. Another idea is that the streams of gas that feed galaxies were just way more efficient back then. Today, star formation is messy and wasteful, but maybe in the clean, dense environment of the cosmic dawn, galaxies could slurp up gas and turn it into stars at a supercharged pace. The rules we see today might not have applied back then. The supermassive black hole connection, a second, more exotic idea, points to a different culprit. The supermassive black holes are the centers of these galaxies. We know that in today's universe, a galaxy size is pretty tightly linked to the size of its central black hole. But in the early universe, that relationship might have been totally different. JWST has found a whole new class of objects called little red dots. At first they just looked like, well, little red dots. But when we looked closer, we found many of them are active galactic nuclei, or a GN. That means they're repowered by rapidly growing supermassive black holes that are eating huge amounts of gas and blasting out incredible energy. This brings up a cosmic chicken or egg puzzle. Did the galaxy form first and then grow a black hole? Or did a massive black hole form first and act as a seed, quickly pulling in matter to build a galaxy around it? These little red dots suggest the second idea might be possible. Some black holes found in these early galaxies appear to be 1,000 times more massive than they should be compared to the stars in their host galaxy. This suggests they grew much more efficiently than black holes do today, maybe giving their galaxies a huge head start. A challenge to fundamental physics. The third, and most radical, idea asks an even bigger question. What if we're not just wrong about galaxies, but about gravity itself? The standard model of cosmology needs dark matter to provide the extra gravitational muscle to form galaxies. But for years, a rival theory called modified Newtonian dynamics, or MON, has suggested that dark matter doesn't exist at all. Instead, Mont argues that gravity itself just works differently on massive cosmic scales, being stronger than what Einstein's theories predict. Proponents of this theory are quick to point out that Mont actually predicted decades ago that early galaxies would form much faster and be larger than the dark matter model allows. Recent analysis shows that the JWST observations of these big, bright early galaxies surprisingly match the predictions made by Mont. This has breathed new life into a controversial theory and forced many astronomers to give it a serious second look. This cosmic detective story is far from over. The answer might be a mix of all these ideas. Maybe star formation was bursty, supermassive black holes did give them a kickstart, and maybe our understanding of gravity does need a little tweak. What's for sure is that we re-caught between different theories telling completely different stories about our universe. This investigation is happening right now. Every day, astronomers are poring over new data from Webb, publishing papers that challenge old ideas and propose new ones. We are living through a revolution in our understanding of the cosmos. To stay on top of this unfolding mystery and see where the evidence leads next, make sure you subscribe and click the notification bell. You won't want to miss the next clue. The new cosmic reality, the discovery of these impossible galaxies, isn't a crisis for cosmology. It's a breakthrough. It's the scientific process playing out right before our eyes. A beautiful, long-held theory has been met with new, undeniable evidence, and it's come up short. This doesn't mean everything we thought we knew was wrong. It just means the universe is, as it usually is, way more complex, more surprising, and more interesting than we ever imagined. The standard model of galaxy formation wasn't wrong, necessarily. It was just incomplete. It gave us a simple, elegant story for a universe that's turning out to be anything but. These new observations are forcing us to add new characters, new plot twists, and new chapters to our cosmic history. We're being pushed to rethink everything from how stars are born to the role of black holes, and maybe even the fundamental laws of gravity itself. The James Webb Space Telescope hasn't broken the universe. It has blown it wide open. It has peeled back a layer of the cosmos to reveal an early universe that was more dynamic, more chaotic, and more creative than we ever dared to believe. The era of slow, steady building has been replaced by an era of rapid, spectacular creation. We are standing at a pivotal moment in our quest for understanding. The clues are on the table, the investigation is on, and the next discovery could be the one that finally cracks the case. The James Webb Space Telescope hasn't just given us answers, it has handed us a much deeper and more thrilling mystery. It has shown us that the story of the universe is still being written, and for the first time, we have a front row seat to the dawn of creation. The only question left is, what other impossibilities are waiting for us out there in the dark?